Let's take a look at simplifying some radical expressions. Here we got an expression with two terms, two cube roots in there. And remember, when we're adding cube roots, we've got to have like terms, like radicals, that is. And so here we both got cube roots. That's a good thing. Under here, though, we have x squared y. Over here, we got a bunch of other junk. They're not like radicals. So first thing we got to do is simplify. So here we can't simplify because these exponents are not bigger than 3. So we got to leave that guy alone. So we have the 5 times the cube root of x squared y. All right, but over here on this guy, we can. So this can be simplified. So let's break it into two radicals. We're using the radical product rule. Over here, we're going to take the things that we can cube root. Now, we can cube root part of these x's because this exponent is larger than a 3. And so if this was x cubed, we could cube root that because the cube root of x cubed is just x. But we got to have the extras over here. Now this simplifies here. So this times this, if we were to multiply them, x cubed times x squared, we'd add the exponents, and we get x to the 5th. So that's good. Here we have some y's. Well, with 3, there's 3 y's and 1 extra. So we're going to put the 3 y's up there and the 1 extra there. So if we multiply this, we would get this term right here. So now if we clean this up, cube root of 27 is 3. Cube root of x cubed is x. Cube root of y cubed is y. And then we have x squared y. Over here we have 5 times the cube root of x squared y. Now, we want to simplify this is our goal, and so we could simplify this, and we will run into cases like this where we want to group these together. The problem is we've got 5 plus 3xy. Those don't really go together very nicely, but what we can do is we can pull out the x squared y, and we could do this. Okay, so this is a bit simpler because we've pulled out the radical there. So if that was our goal, we could do that. So in a way, it's simpler. Now let's look at a problem where we're going to multiply two radical expressions. All right, and so we're going to treat this just like we would multiplying a couple binomials. And so we have 2 times the square root of 3 times the square root of 3. Well, that's just 2. And the square root of 3 times the square root of 3 is the square root of 9, which we'll clean up in a second. And then we've got 2 square root of 3 times 3 square root of 5. Multiply those things outside, the 2 and the 3. And then the things inside, 3 and the 5. And it's going to be minus, because of that right term is minus. So we have 6 square root of 15. Multiply the inside, guys. Square root of 15. Multiply the outside ones. So that's going to be minus 3 square root of 25. And we'll clean that up in a second. Okay, the minus here came from positive times a negative, gave us a negative. Okay? So this becomes 2 times 3, because the square root of 9 is really just 3. So this is 6. And then we can combine these two guys. We got negative 6 square root of 15 plus a 1 square root of 15. That's going to be a negative 5 square root of 15. And then over here we've got a 3 times a square root of 25, which is really 3 times 5. So that's 15. And we can combine these outside guys, 6 minus 15, because they're just integers. Negative 9 minus 5 square root of 15. And that is simplified. All right, we can't put those together because one of the terms has a square root of 15, one does not. So we have to leave them separate. So distribute it a lot like you would two binomials, and see what it simplifies to. A little bit of division now. Simplifying these guys is a little different because we have two different indices, a cube root and a square root. Remember, when there's nothing here, it's squared. All right? So when we have different indices, we want to use our rational exponents. Rational means fractions. So let's take that inside stuff, a squared, b to the fifth, and let's put that to the 1/3 power. Let's take the inside here, ab to the third, and that's going to be to the 1/2 power. Okay, remember, fractional exponent indices become the denominator in that fraction when we're writing things as rational exponents. All right, so there we go. And then we have our rule. Now that we have all these exponent rules that we learned when we were dealing with exponents that weren't fractions. Same rules apply. Fractions are just numbers too. So, they got feelings. They're numbers too. So we're going to multiply. A squared gets raised to the 3rd power. We multiply power to power. And b to the 5th is raised to that power. So we're going to multiply power to power. Okay, so we're going to multiply all these exponents. That is our power to a power rule. All right? And so a squared to the 1/3 is going to be a to the 2/3. And the b is going to go to the 5/3. Okay. On the bottom, we have a raised to the 1/2 power. And then the b cubed raised to the 1/2 power gives us 3/2. Okay. 3 to the 1/2 power. Okay. All right. Well, now what can we do with this? Well, we have a rule that can tell us that when we're dividing powers that have the same base, now we got a base of a and a base of a, we can subtract. These guys up here did not have the same base. This stuff in the parentheses was not the same as this. So we couldn't do those whole things together, but we can do these ones separate. Let's deal with the a's and deal with the b's. We subtract the exponents, so we've got a, and we've got 2/3 minus 1/2, and we've got b, and the power on that is going to be 5/3 minus 3/2. All right? And to do that, we're going to need some common denominators. Going back to our subtraction of fractions, common denominators is 6. So let's make this into 4/6 and 3/6. And we'll clean that up in a second. This guy is going to be top and bottom times 2, 10/6 minus, and this will be 9/6. And that ends up being a to the 1/6 and b to the 1/6. Well, that's kind of nice. They both came out to be the same. So let's write that. Let's pull that 1/6 out. That's a b to the 1/6, which is the 6th root of ab. At this point, you might have, maybe that last few little steps is a little weird for you there. So an alternate ending, okay, kind of like you get on your DVD when you want to watch your alternate ending. Here's your alternate ending. You could say this. You could say that we have the 6th root of a times the 6th root of b. And so now they both have the same index. We can go ahead and multiply those things together. Multiply a times b, put them on the same radical. There you go. So whichever one you like, you can use there. That's the cool thing about these power rules and these exponent rules and these radical rules. They all work together. So find one that makes sense to you and go with it, either going this route or this green route over here. All right. So that's how we simplify these different radicals. let's look at one more kind of a challenge problem, all right? This looks crazy. We got a square root here and a cube root, some parentheses. What's going on here? Well, we're going to do the same thing, use our fractional exponents. You might be tempted to multiply this out, but don't. That would be ugly. So let's leave it alone. So we got 27, a to the 5th, and then we've got b plus 1 cubed. Now, you might want to pause the video and try this yourself here and come back and check it, but we'll roll right through here. A, b plus 1 to the 1/3, all right? And let's apply that power to each of these. We've got 27 to the 1/2 power. We've got a to the 5/2. We've got b plus 1 to the 3/2. We've got 81, so times, let's get that out there. Let's just go times 81 to the 1/3. You know, now that I started this, this is getting kind of crazy. This might be a route that, well, I'll finish it up real quick, and you can decide if you like this route, or I'll do another route that you'll probably like better. Okay? So let's see what we can do here. I'll do this all in fractional exponents, and if you understand the fractional exponents well, then cool. If not, then wait for the second ending. You're going to say that was a whole lot easier, maybe. Okay, so let's see what we can do. So 27 to the 1/2 powers, let's break it up. 9 to the 1/2, 3 to the 1/2. Okay, because we can deal with this part and not the other one. All right, here we've got a. Let's break this up. A to the 4/2 times a to the 1/2. Again, I can deal with this part, and we will in a second, but not that other one. So I'm doing the simplifying without all that radical business. Here, let's break this into b plus 2 to the 2/2 times b plus 1 to the 1/2. All right? So I just broke it up into things that I can simplify and things that I can't. Okay? Here, 81 to the 1/3. Well, 81 is not a cube root, but there's a 27 hiding in there. 27 to the 1/3. Or you know what? Here, let's go this route. This is good. Okay. 81 is 3. Oh, yeah, this is good stuff. All right, 81 is 3 to the 4th. So this is 3 to the 4th to the 1/3. And let's write that as 3 to the 4/3. That's what we should have done back here. I'm going to come back and I'm going to clean this up. 27 is 3 to the 3rd. So this is 3 to the 3/2. Okay? You can think about that for a moment, all right? That's why this is a challenge problem, all right? And this guy over here is a to the 1/3. Oh, I like where this is going. And this is b plus 1 to the 4/3. Okay, I'm going to backpedal a little bit, all right? I know I'm going in some circles here. Let's forget all this mess. Let's not do the simplifying first, okay? So, I'll put this back here. Okay, this is going to work. I like it. I see where it's going. Do you see where it's going? You're saying no way. Okay, so we don't need to break that up yet. We got a little ahead of myself here. Okay, so I just I kind of put it back there. Sorry, we went one route and changed our mind. That's okay. We can do that. All right? That's what erasers are for. So, what happened here? Well, this is 27 is 3 to the 3rd, and we took 3 to the 3rd to the 1/2. All right? Because we want to see, you know, to the 1/2 there. 3 to the 3rd to the 1/2 is 3 to the 3/2. Right there. All right? And then we took this 81 and we're going to write that as 3 to the 4th. 81 is 3 to the 4th to 1/3. That's where that helps there. Okay, and now the reason that that helps us is we've got these bases that are the same. And now we can do what we did in the last problem. Let's take the bases. We have 3 to the 3/2 plus 4/3, because this is all multiplication, a bunch of multiplication in here. All right, and we've got a to the 5/2 plus 1/3, and we've got b plus 1 to the 3/2 plus 4/3. Okay, so we have, now we're going to add those exponents. So this is going to be 3. We need to get 6 as our common denominator there. So let's go ahead and get our 6. This is a 9/6 plus 8/6. And then our a's, let's get common denominators. And that's going to give us 15/6 plus 2/6, just getting common denominators for here. And then our common denominators on our b plus 1 look about like this, all right? And so now we have the same bases. Okay, we combined them here. We can add the exponents because it's all multiplying, and we can clean that up. We're just about there. Let's add those exponents, and we've got 17/6 a and 17/6 and b plus 1 and 17/6. Well, that's kind of cool. They all came out to be the same. We're going to have some things that come out of the root and some things that get left in. So we're going to have a 6th root. I'm going to put that here for the leftovers. 17 divided by 6 is, well, so the biggest we can get in there is 2 6s. Okay, so that would be 3 to the 2nd power. 3 to the 2nd power. And because this is like 2 and 5/12, so we'll leave 3 to the 5th behind. And then we have same story here, a to the 2nd, and a to the 5th gets left behind, and then the b plus 1 squared, and left behind b plus 1 to the 5th. And I put those all in their 6th root there, and we're pretty much done. We guess we could clean up the numbers, and we have 9a squared b plus 1 to the, that was the 2nd. It's a little bitty 2 down there. And the 6th root of 3 to the 5th, oh boy, that's going to be 81 times 3, 243 is what it is. A to the 5th, and b plus 1 to the 5th. Whew! Let's leave it there. Forget that alternate route I talked about earlier. There is no better route. That's the way to go. And that's why it's a challenge problem. All right. Hey, if you made it through that journey, congratulations. Our red and green stuff here looks like Christmas. It's probably Christmas time. So anyways, good luck, all right? We won't do a lot of problems in class like this probably, but if you can do this problem, you can simplify just about any of these. All right. Keep up, just keep using those exponent rules and simplifying one step at a time, and you'll get there eventually, even if you go in some circles like we did here.